welcome back. This is Krishna and welcome to AI Martian. Yesterday in last session, we talked about Kaggle, like how to get the data to train our model because we cannot go to market physically and can collect the data. It will take a lot of time and it will ask for a kind of huge manpower. And of course, we are learners, so we do not have some sort of resources, right? So in that case, what we have to do? So that's why I talked about Kaggle. And today I'm going to use Kaggle and MSE, and I will train a model. I will show you like how can we use loss function like MSE, which I have teach you last to last video. Okay, so I'm going to simply implement that. Uh, so let's go to Google Colab Sheet, and I have already written some code there. I would explain each and every line of the code over there, and you guys will betterly understand. I would request you to make a note of it parallelly so you guys will understand betterly, all right? So let's move to Google Colab Sheet. So here I have mentioned use mean square error MSE in code to a deep learning model. So there are some steps I have introduced though. So step first is like, first of all, I have to import required libraries. But the most important thing is data. I don't have data right now. So how can I get that data? So I simply went to Kaggle. This is Kaggle. And if you'll go back, you will get this one. I also provide you a link because I already upload this sheet after downloading in my Google Drive. I will give you access where you can click. That would be in description, where you will click and you will simply get the data and you can easily train your model, okay, using which I'm training my model. So uh salary data set is there. Okay, if you will click on this, you will get this salary data set which is created by Alina Venkata Sai Abhishek. All right, there was some guy 2 years back, he updated, so he also used the same data set. And here is the button using which you can download it. So you will simply click on it and you will get an archive file. So see, this is archive 5 zip. I'm getting here 457 byte is the size of this file. So we have to go to downloads. We have to unzip it. I already did that. Okay. Let me show you. So this is the data. If you'll go to downloads here, I'm getting archive 5. If you'll click on this, you'll get this data set. But because this is a zipped file, you have to unzip it. So for that, you have to simply click on this and you have to click on extract all. So it will simply give you a folder which name archive 5 where you'll get salary data set. Now what did I do? I simply put this data set in my drive, and because I'm using Google Colab Sheet, I can internally load a drive in Google Colab Sheet and I can use all the data which is available in my drive. Okay, and that's a secure way. Means why it is secure, I will let you know, but not now. Let me show you this. So I simply upload this data in my drive. This is my drive. I created 1 second. In my drive, this is my drive, okay? In my drive, I created a folder, deep learning. Let me check. So this is home, deep learning data set I created. So in this data set, 1 second, this is, I think I have to folder of same type. So let me explore it a bit. My drive, deep learning tutorial file, this one. I simply clicked on it, and this is that file about which I'm talking, salary data set on .csv. This is something which I don't require. Last night I was trying to make it, so that's why it's wrongly configured here, the second one. So I don't need this. I'm removing it. I'm simply moving it to trash. So this is my data set. I also provide you the link of this. So let me share with you guys. Copy link. Okay, 1 second. Share. So what I'm doing, I am just making it like anyone can access, right? So now I will provide you this link, okay? In the description, the description would look something like this, okay? So this is the link in my I will put in my description, and you guys will simply click on this and you will get the data, okay? You must have authority to download it because I authorized you in using this drive. So now the same drive I want to use in my code. So how can I do this? So see the button over here. I just want to click on this first of all to make it like the previous one. So just uh, uh, just reload it because it's still connecting. I removed this, right? And that's why it is connecting. Now it is connected. I can see here two kind of folders, sample data, and this is a kind of back button, okay, you can say. So 1 second. Home. Okay. No need to do any kind of thing here. You have to simply click on this. So you guys are connected with this kind of email ID. So this email ID, Google also provide a drive. Okay. So you guys can simply click on this and drive will get connected to this Google Collab sheet. Okay. So it is asking me permit this notebook to access your Google Drive file. Means it is asking, Google is asking for permission whether you want to use your drive here or not. And for that, if you want to use Google Drive files, you can simply click on connect to Google Drive. So I am clicking on that, and once it will connect it, see it is saying mounting. Okay, once it is connected, then just 1 sec. Yeah, so in content section there is drive, okay, and there is my drive. Okay, so I have to simply go to content. I'm clicking on it. Okay, so this is the content. In content, I will get a drive section, and here is the drive. Okay, so once I will click on this drive, I will get my folder deep learning tutorial. Once I will click on this, I will simply able to click on this salary data set. I have to click on the path, copy path, and that copy path I have to provide. I have to provide here. 1 second. Here you have to provide that path. Okay, here you have to provide this that path. Okay, why I put R here? R means whatever I have mentioned inside this. Okay, that should read without having any kind of affected, like see, if in Python you will mention something like this. Let's say here we have T. Okay, so that's a tab. Okay, that's a 4 spaces, 5 spaces, 6 spaces according to Python. So to not to make such kind of changes in your string with such kind of forward slash button, you have to simply put R there. Okay, so R will simply treat it as a raw string. Means it's a simple string. There is no any kind of changes that Python have to internally do. Okay, so that's why we use R raw. These are the important libraries. So for our coding start from here. Okay, see, this is the important library which I have to use to train my model, to filter my model, to scale my to train my model, to filter my model, to scale my data set. Okay, everything is there. So all important library I already have mentioned here. So first one is NumPy. NumPy used to process unstructured data, which either in 2D, 3D, 4D, or in dimension of array. All right. So I already taught about NumPy. If you didn't know what is NumPy, please go through my playlist section. There is NumPy video available. And import pandas. That's the second library. And this NP or PD is nothing but the short name of this NumPy is NP, and short name of pandas is PD over there. So now from sklearn.model.selection, there's a kind of library available in Google. Okay, that's called sklearn. Sklearn is used for machine learning kind of stuff, and there we have some tools which we have to use. Okay, and that's why I used sklearn here, which is train testability. You can do it manually, but that's already available in sklearn, and that's why I am importing it, because I have to split my whole data into two parts, in training part and testing part. I already have taught you like what is training testing most of the time. So if you are doing wildcard entry in this video, I would request you to go from the very first video. You will able to figure it out like what I'm talking about. And you can also go to my machine learning section so you guys will better understand, because I have taught these things over there very well. Now, the second one is pre-processing. So after downloading or reading the data, let's say this is the data path. Okay, I'm reading that data, they're contained in this variable. Okay, and this variable I will use for further model training. So whole data will get stored inside this variable, but not only read the data and I have to pass to the model. I have to do some pre-processing, like I have to scale them between 0 to 1, min-max scalar, binarizer. There are a lot of scalars, standard scalar. Here I'm using standard scalar. Okay, so these are a kind of technique using which we uh, try to create our data. We try to transform our data between a range. Okay, so none of the data will behave like an outlier here. Okay, I have explain all this term in my playlist, so please go through this video from the start. Okay, now this is TensorFlow. So TensorFlow I'm using to train my deep learning model, and this is all, again, the short name of TensorFlow, because I cannot mention TensorFlow all the time. It is really hectic to mention each and every time TensorFlow stuff. If I will do any kind of mistake in TensorFlow kind of spelling, it will give me error, and for that I am using aliasing. Okay, and here we have TensorFlow Keras model have a sequential kind of model, like method, which I have to use. Sorry, sequential kind of class which I have to use to train my model, to mention my neural network. Like in outermost layer, I have 10 neurons. In hidden layer, I have 20 neurons, and outer layer, I have 1 neuron. So such kind of thing we always try to mention in the sequential class. Okay. This is the dense method which is available inside TensorFlow Keras layers. So inside TensorFlow, there is a module called Keras, and in Keras we have again a sub module called layer, and in that we have a dense method. So, or class, you can say. This is the class which we use to mention our layers. Okay, like in first layer, in outermost layer, or in input layer. Let's say I have 10 neurons. Okay, let me show you. Let's say this is my input layer. Okay, this is my first hidden layer, and this is my, let's say, output layer. Okay, this is my first hidden layer, and this is my output layer. Okay, so to mention like how many neurons are there, we use this. Okay, to mention how many layer should be there in middle one, so I will use dense. For output layer, I will use dense. But to keep these all three layers inside a array, that is called sequential. Inside a sequential is a kind of array in which we keep our layers. Okay, so this is what we are using here. I will show you, but just for the explanation, I made it. Let me clean this. So I imported all the important libraries, but if you want to remove it for now, you can remove it. Why I mentioned it, I will tell you that. So step 2, load a data set examples. Okay, so this is what this is how I load my data set. Okay, pd.read_csv, and this is the path which I have told you, like you have to simply go here in deep learning tutorial. I will also provide you the link of this data set. So you guys can simply copy this after right click on this. So I'm right clicking on this. Okay, salary data set, I'm right clicking on this, and I'm simply copy this path, and I will simply do what I will, let's say, removing this. Okay, so with two double quote or single quote, you can put your values there, and just to use it as a raw string, so you can mention R there in front of it before double quote. Okay, otherwise it will give you error. So let me read it, and I also print the data, so you guys will able to understand. Okay, now it is saying PD is not defined. Okay, I also try to print the data here. Okay, but it is saying PD is not defined. Now what is PD? PD is nothing but pandas. So I didn't run this shell. See, I didn't run this shell. Let me run it. Now it is running. Okay, so once it will run, the task will execute. See, 7 seconds it took. Okay, now I am running this. It will fetch the data, and it will show me that data. See, it is showing me that data. So yesterday I told you there are 3 columns. Okay, but this is nothing but the indexing. Indexing never play role while training a model, because indexing is not a feature. It's simply a kind of value which we assign to any random person, like 0, 1, 2, 3, 4, a kind of roll number, you can say, or a kind of entry human make in their vocab in their notes, like in the register, like this is the first person, this is the second person, this is the third person. Let's say I have a gym. Okay, and I want to make a note like how many people enter every day in my gym. So I will use a registered, and I will mention simply there 1, 2, 3, 4, 5 kind of indexing, and I will start writing their name in front of the number. So that's not a feature. Okay, the feature is what? Year of experience. This is the feature column. This is the feature column, and this is salary. This is I'm going to use as a target. Okay, so I will simply train my model using these 2 columns. Okay, this is the feature, the first column, this is the target, my second column. Okay, of course, the feature is very less, the data is very small. Maybe I will not get better result, but just want to teach you like how we train a regression kind of model. That is why I am uh, showing you this stuff. Okay, let's move ahead. So I successfully import the data. I successfully read the data path and import it. So it is now available in a variable called dataset. Let's move ahead. Again, step 3, that assume feature contain your input features and salary is the target. I simply mention here like year of experience is the feature and a salary is the target. Okay, now what I need, I have to split them. I have to split year of experience and salary column separately. Year of experience should be in you can say 2D array. Okay, and target, you mean salary, should be in 1D array, because I already taught you like year of experience or the feature always exist in 2D array. Okay, and target always exist in 1D array until it not until nobody's in one until nobody's implemented one hot encoding on that. Okay. Now again, step 4, split the data set into training and testing set. Okay. So now here I use train test split, which I imported from sklearn on the top. So sklearn is a library where train test split is available, and train test split help us to split our data into 2 parts. Okay. So suppose this is my data set XY. Okay. If you want to see, you can see, I will show you 1 second. Print X. Okay. So it will only show me year of experience. See, year of experience, it is in 2D array, right? And if you also want to see the target, let's say I want to show you the target this time. So it will be in 1D array. See, this is the target in 1D array. Okay. If you want to label it, I can do that. So let's say this is year of experience I'm writing. This is year of experience, which is X, and this is salary. This is salary, which is Y. Now it will notify initially. See, year of experience is a 2D array and it contain multiple data up to here. This is the year of experience. Now this is the salary. Salary always exists in 1D array because this is a target I'm going to use in my model. Okay. Now after that, what I have to do? I have to split the data into training and testing set. So for that, I am using train test split, but I can also use manual stuff, but it's already there in SQL, and that's why I'm using it. And I would request you to go to machine learning playlist. Okay, you will get these stuff over there because the initial approach before starting deep learning or generative AI is machine learning. If you are not aware with machine learning, you cannot directly learn deep learning. It is very complicated. I'm not saying nobody can do. Of course, you guys can do, but for that you need initial knowledge. And these are some initial knowledge which I'm using in deep learning as well. Maybe I will use in reinforcement learning. Okay. So, sorry. So after splitting the data into two parts, now what happened here? Let's see. So let's say I have the data set. Okay. I have data set. Okay. This is my salary. Okay. This is my, uh, 1 second. This is my, let's say, year of experience. And this is my salary. Okay. So there are two kind of column I have. This is called X and this is called Y, which I have already shown you above. So now I want to split that data into 4 parts. Okay. How can I do this? So if you guys are thinking like me, like it is split into 4 parts, that is wrong. Basically, our data is going to split into 2 parts. Let's say here I have 1.2, 2.3, 4.5, 7.8. Okay, let's say I have a 4 data set for now. Okay, just I want to make you understand this. First person having 1.2 year of experience getting salary of 10,000 and 2.3 year of experience candidate having, let's say, 20,000 of salary. Okay, 40,000 the third one, and a fifth candidate, let's say, getting 70,000. Okay, now I want to explain according to this line. Okay, so here we have X train, X test, Y train, Y test. X train and X test, Y train and Y test. These both are same. These both are same. Okay, how? So this is X, let's say. So here I have mentioned test size. Here I can see X test and Y test. Okay. Now, test size is 0.2. 0.2 means, let's say my whole data set is 100%. And in machine learning, 100% used to represent by 1. Okay. So if 1 is not there, the test size that is mentioned is 0.2. That means 20% of data, let's say I have this data. This is what? 100% of data, which I will use to represent by 1, let's say. And in this 100% of data, I need 20% of data, which is represented by 0.2 here, is going to split into Y test, sorry, X test and Y test. X test is the feature and Y test is their target. X test is the feature. This is, let's say, I'm splitting this data into 2 parts. Okay. This is my X train. This is my X. Sorry, this is my Y train. Okay. So see, this is my X test, X train, and this is my Y train. This is my X train. This is my Y train. Okay. This is the feature. This is the target. See, this is the feature. This is their target. Similarly, this is X test and this is Y test. This is the feature. This is the target. Okay. So X test and Y test are here. Okay. Let me use another color for Y test. X test and Y test. There are two kind of data set we have. X test, Y test. X test, Y test. Okay. So I need feature as well as target. So why I'm splitting this data into two parts? And what is this? Random 42. So see, each time when we run this shell, if I will not mention it, let's say, I'm removing it. And if I'll start running this, the sample of X train and Y train may be changed. Maybe this will go up and this will go in X test. So always it gets changed if you will not mention a static value there, random state like this, like value. Random state 42, this value may be anything. Okay, not minus, but 1, 2, 3, 4, 5, 6, 7, anything you can mention. That means it simply memorize like how your data gets splitted into two parts. What was the configuration? Like initial these three values in X train and these one value in Y X test. So it will memorize this. The sequence name it is keeping 42. That's why we used to mention a random state 42 just to keep remember the sequence. Okay, because if you will not mention it, if you'll start printing the value, it will simply give you changes each and every time. I will show you. Let me clean the window. So let's say my X train, just for now, I'm just taking X train. Okay. See, X train, I'm getting 10.4 initially. Okay. Again, if I will run, I will get the same value 10.4, 8.8, 4.1. Just keep remember this thing. Okay. 10.4 is the first value, 8.8 is the second value. Let me run this again. I will get the same value 10.4, 8.8. Okay. But if I will remove it, let's say I'm removing it, and if I'll run it again, the sequence get changed. Now I'm getting 3.3. Initially I was getting 10.4 and 8.8. Now what I'm getting 3.3, 9.7. If I will run this cell again, I will get different value, not 3.3 this time. See, I'm not getting 3.3. So each time the value get changed. Okay, and that's why we use random state. Okay, so let's say again I'm using random state there. Let's say 42, it will give me the same 10.4, 8.8. See, I'm getting that. So that's nothing but a kind of marker using which your configuration memorized by the modem. Okay, by the PC. Okay, by the RAM. Now here what I have here is the feature scaling. Now see, if you will see this data is 10.4, 8.8, and 1.2. So this is a huge number of data, like 10 times more than this, right? So to keep the data between same range, between 0 or 1, or between the same range, okay, we have to pre-process the data. We have to scale the data. We have to scale the data. And for that, I'm using standard scaler. I can use min max scaler as well. So standard scaler is a class. Okay. Standard scaler is a class which I already imported here from a scaler. So scaler.preprocessing import standard scaler. Let's go down. So here Standard scalar is a class, so you have to create object of that class. If you are not familiar with what is object, what is class, so I would request you to go to my Python playlist. There I have teach every kind of corner of Python and object-oriented programming. So this is the concept of object-oriented programming again. Okay, this is a chain. Okay, you have to start from Python, then you have to go for database, then you have to go for the statistic, then you have to go for machine learning, deep learning, NumPy, pandas. So it's a kind of chain. It always start from you can say Python. Okay, so standard scalar is there. So I'm simply creating an object like standard scalar parenthesis. I have to assign it to a variable that is called object. So this is object. Scalar is an object of the standard scalar class. So X train scale, this is the variable. This is just using to store the data, like what kind of data I'm storing here. So X train, remember this is X train 10.4, 8.8, 4.1. Okay, X train. I passed X train here. Okay, and when I will print this, print X train, just to make it visible, I'm just using something like this. It will scale the data. One second, guys. Oh, my bad. I'm sorry. I didn't mention here scaled. I have to, because I stored after scaling the value into this, right? Is an X underscore train underscore scale, right? So I have to run this and see, I'm getting my value between 0 and 1. See, means in a range. Okay, it is not between 0 and 1. It is not min max scalar, it is standard scalar. So it is simply trying to convert my data between a range. Okay, let me show you standard scalar. Sorry, min max scalar. I'm using min max scalar. Okay, min max scalar I'm using, so it will be more understandable. Okay, that's why I'm using it. Let me run this. Okay, so here I'm using, let's say, min max scalar, and it will convert my data between 0 and 1. So see, this is between 0 and 1. See, 1 is the maximum value, 0 is the minimum value. Can see, right? So it simply converted my value between 0 and 1, the whole value. Okay. Now, similarly, I have to convert my X test. Now, what is X test? This is my X train, right? So X test is the remaining part. X test. That's again the feature. Okay. So here we have smaller value because 20% of data of the whole I'm using here as a X test. So it is 97.5, 8.3. If you will convert this into again between 0 and 1 using min max scalar, what you can do, you can simply have to pass it to transform. See, I passed X train with fit underscore transform. Okay. But when I'm scaling my X test, it is passing they if I wanted to scale my X test, I'm simply passing it with a transform kind of method. Why? Because I want to use the same scale which is used here to here. Okay, I don't want to create a new scale for this. Okay, I just want to create, I just want to use the same scale which is used here to scale the data between 0 and 1. Okay, so maximum value, one second, let me print both. X test, okay, and this is X test, the value. Similarly, I just want to show you Y test, print Y train, okay, and I need their value y train. So see, I'm getting both the values now. Y train. I think I made some mistake. It is X train. Sorry, not Y train. It always happened. So if you will see this, 1 second, let me change the name also. It is X train. Okay. So if you'll see this X train, in this, the maximum value, I guess, is 10.4. Okay. From here to here. No, 10.6 is the maximum value. Okay. Let me search. Yes, 10.6 is the maximum value in X train. But in X test, 9.7 is the maximum value. So think about it. If I want to convert this all value, this X train between 0 and 1, what I can do, I can simply divide all the values by 10.6 and I will get all the values between 0 and 1, right? So I just do it using fit underscore transform. So fit underscore transform do two things. First, find the maximum value, and second, it divide all the values by the maximum value. Okay. All right. Now, when we want to convert our X test, okay, into 0 and 1, the same scale which is used here in X train, okay, the same scale which used in X train, which was 10.6, we use same scale to convert this X test between 0 and 1. Okay. Why we are doing this? For the relation, because these two data sets are the part of single data set. I break them down into two parts, right? And that's why I have to use here transform, okay? Not fit underscore transform. If I will do fit underscore transform, it will consider this as a maximum value and it will divide all the values of X test to scale them. And there, the relation of these two data set, X train and X test, will not exist anymore. Okay. Just for that, we need similar scale. And for that, we are using transform, not fit underscore transform. Fit underscore transform do two things. Find the maximum value. Okay. Or in simple word, you can say find the new scale and convert all the values according to the scale. Transform do one thing. It simply convert all values using the previous scale, what it find it here. Okay. So this is the only use. Okay. Now let me run this. So my data set got scaled. Okay. If you want to see, I can show you X train scaled, and I want to get the value of this also. Print X test scaled, X test scaled. I will get scaled value. Okay, this is X train scaled value up to here. Okay, and this is my X test scaled value. Okay. Now, I just want to make your attention on one thing. Like we never scale our target. This is feature. X train is a feature. X test is a feature. Okay. Y train, Y test. This is the target. Okay. We cannot scale target. Never use to scale them. Okay. If you will scale your target, you will get bad result always. You will get error. You will not get what you are expecting to your data. Okay. So moving ahead, let's build our model. Now, two ways are building the models. Okay. The format of writing the model are two types. The first one is this, which I have already taught you. Okay. Sequential, then dense, then this is what? Let me explain you that. This is the, let me clean the windows first of all. This is my first way. First way to write neural network. Okay. And this is second way. second way. Okay. There is no changes, nothing. There's the same. Okay. But the writing sequence are different. Okay. Here I'm using model sequential parenthesis. This is the parenthesis, a square bracket, and I'm closing the same. Okay. I'm closing the same with a square bracket and parenthesis. Okay. Here I'm using sequential and I'm using add to mention these three row. Okay. See, 64 I use, dense 64 I use, everything is as it is. See, dense 64, this is as it is over here, right? After that, dense 32 activate value. See, dense 32 activate value. I'm simply mentioning it what? Model.add. Okay. And the last one is dense 1. See, dense 1. Again, I'm using model.add. So there is no change, nothing. Okay. You are mentioning each and everything between these parentheses in this case. That is also true. Okay. Keep this thing in mind. Okay. So I mention it here because I want to tell you about it. Okay. You guys will see most of the time like the other way also. Okay. This way also. So I don't want you guys to get confused like what Krishna is teaching you and what you are getting in the market. That's why I mentioned both the sequencer, right? Now let me clean this window. Moving ahead. This is what I created. I created my neural network. Okay. My neural network. I created my neural network. Okay. So in the first hidden layer, I have 64 neurons. Okay. In the second hidden layer, I have 32 neurons. Okay. And in the output layer, I have 1 neuron. Okay. And there is a input layer of shape size this. This is my input layer. Okay. Like this. All right. So this is my input layer. Okay. This is my first hidden layer, second hidden layer, and output layer. First hidden layer, second hidden layer, output layer. Okay. And this is my input layer. I told you about it in the initial classes. Okay. Like in the very first row, this is the very first row. You guys will get confused most of the time. Like, is this the outer layer? Is this the first input layer? No, this is not first input layer. This is first hidden layer, right? Where we have 64 neurons. All right. So keep this thing in mind, okay? And what is then input layer in that case? In that case, the input layer is X-trend shape 1, okay? Now, let me clean this. Moving ahead, what I have to do, I have to compile the model with MSE as loss function. So after mentioning neural network, we have to compile our model. And for compilation, I need few parameters like optimizer, losses, and matrices. Okay. So I taught you about mean square error, about which I'm just teaching you here right now to how to use mean square error in your model to train. Okay. So here I'm using mean square error. See, I'm using mean square error as a loss function. Okay. So mean square error, and this is matrices where I was using accuracy score. Okay. So I'm using MAE, mean absolute error. I will teach you about it also soon in the upcoming classes. Okay. And this is my optimizer Adam. So here in classification kind of model, you use binary cross entropy, categorical cross entropy that was recommended there. But in mean square, but in regression model, where we do not have class, here, we have random value. Okay. So in that case, you have to use mean square error, mean absolute error. Okay. So such kind of losses you have to use. After that, this compile is also there in classification model. Okay. When I was creating, there's compile method also in which we mention these 3 parameters. Okay. And this is what my model dot fit, okay, where I'm passing my X train scaled data, okay, Y train, see this is not scaled, okay, epoch is 50, like 50 time it will train the model, okay, and it try to reduce the loss, okay. This is the batch size, like suppose I will teach about it. Batch size is a different concept. It's a big concept, okay, I will teach about it. So batch size means let's say 10 people it is checking, okay, and this is validation split 0.2, okay. So it's a kind of validation, I will also teach you about it, okay. So this is a kind of, while training the model, just leave it for now, okay. It is very much complicated. So see, if you will run this, if you will run this, oh, it is saying model is not defined because I didn't run this shell, okay. All right, now run this. Now model get compiled, and this is where our model started training it, okay. So see, it is training my model and the training was very fast. See, I'm getting a lot of values there. I'm just minimizing the screen just to see all the values at once. But there is a problem. What is the problem? I'm not getting MSE down. I'm getting loss very high. Okay. This is MSE. MSE is a smaller value as compared to loss function. This is MAE. Okay. MAE is the mean absolute error. And this is the loss where I use mean square error. A square value is the more, right? So this is a bigger value. This is the loss of my testing data, okay? Like my when I was training the model, no, in validation split, 20% of data I'm using every time at the end of every epoch to get like how my model get more precise, okay? So I just would like to say it is not getting modified. See, the whole value are same as it is. There are very few changes at the end. You can see 96, 880, 1676, 112. So that's a very small change. See, very small change here as well. So this is because of lesser number of data. We have a very short amount of data. Let me change the epoch. Okay, let me change the epoch up to 100. Okay. And batch size, let me change up to 5. Okay. And run it again. It is trying to reduce initially 76,000 MAE, and losses was also like the same 66,000. See, still there is no change. Okay. Very minute changes there. Okay. So this is a kind of model which I cannot deploy in the market, but just to show you like this is how we train our regression model. Okay. One more thing, guys, one more important thing. You have to understand, like, we cannot train a deep learning model with smaller number of data. I have 35 data only. Okay. 35 data only in my data set. If you can see, not 35 also, 29 data set, 30 you can say, because indexing start from 0. See, so there are 30 samples only. With 30 samples, you cannot train a deep learning model. That's why you're getting such a bad accuracy, right? So always keep in mind, when you have large amount of data, then only you use deep learning model to train. Okay. Now this is to evaluate the data, like what was the loss, what was the MAE, mean square, mean absolute error. Mean absolute error I will tell you in the upcoming classes. Okay. So this is the overall loss of my model. Okay. And this is MAE of my model, mean absolute error. This is also kind of error. Okay. So this is the test MSE like mean square error, overall error of the test data, and this is the overall mean absolute error of the test data. Okay. So prediction. Now, if you will provide any kind of data to it, it will simply give you the prediction. Okay. So let's say, just comment it, model which I have created. If I'm asking like what should be the salary of a 10-year candidate? Oh, sorry, it should be in 2D array. Okay. So it is saying 29,048.878. This is very bad result. Okay. Because 10-year candidate having like 10,000 of salary. Let me just rerun this. Yes. Okay. So it is a bad result. It is not something what I was expecting. I see if you will see your data, no, if you will see your data, you can see here 10-year of candidate having 1,22,392. 12 lakh, sorry, 1,22,392, 1,21,087 kind of data they are getting. But in my model, when I train this model and when I'm asking like what should be the salary of 10-year guy, it is simply saying me 29,048.87. This is something which I was not expecting, all right? So this is a worst model, okay? But just to learn these things, like yes, we are able to get the knowledge, like how to train a regression class or model, how to train a regression model. We can consider this, okay? But once we have huge data, we will definitely train a good model. So this is the final stage I have mentioned. I have mentioned all the code in single shell, okay? Single shell, and I trained it. The same value I will get, okay? I didn't make much changes. I simply have to enhance the epoch and batch size. Everything is same. It will train your whole model at once in single shell, okay? And this is how training look like. All right. So as epoch goes high, the losses will reduce, but data is very short, okay? So we are not able to train it. Hope you guys understand this. Okay, like what is a regression? My motive in this video is to show you like how we can use MSE in our model training. So that's why I just created this video. And in the upcoming session, I will talk about mean absolute error, MAE, which I have shown you in this lecture. Okay, so hope you guys understand this. If you really enjoy and like this video, please like, share, subscribe, share with your friend families, and thank you. Bye bye, guys.